Hello, everyone. I'm the second introduction act here. 11 years ago, I met Ben in MIT, and we built this tool we call the Reality Editor, a tool to connect and control the connected physical world. And here we are 11 years later. In between, we met the executive team from PTC, and they thought, this is some cool stuff you do. We're really interested in this whole space of spatial computing, and we want to figure out what's out there, what's beyond the horizon, what's the uncharted territory. And so together with the executive team from PTC, 7 years ago, we started the Reality Lab as a little bit of an evolution to the Reality Editor. And so I want to hand over, so to say, the mic to Ben. He will show you what we have done all of these years at PTC. I'm going to go back to the seating area.
All right. Thank you, Valentin, for that introduction. Good afternoon, everyone. Thanks for being here for such a late session in the day. We have a lot of really cool things to show you, so thanks for sticking around for this. I also wanted to give a shout out and a thank you to the rest of our team at the Reality Lab. In addition to Valentin, who I've been working with for 11 years, we have James, who's been on the team ever since the beginning, and then a whole bunch of other really bright people who have built all these demos that we're going to show to you today. So a shout out to them. And now I'm going to give a brief kind of overview of the arc that I'm going to take you on today. The spatial story of the PTC Reality Lab involves taking the spatial programming work that we started at MIT and really bringing it into the industrial focus that PTC as a company has. So PTC is a software company that focuses on making CAD software and data management systems for industrial companies. And we really found that the factory, where PTC is focused on, is a great place to explore spatial computing. Compared to exploring it in a home environment where maybe you only have a handful of connected light bulbs or a Nest thermostat at home, in the factory there's just tons of spatial problems to solve, so much data there, and it's really been a fun playground for us to build out all of these concepts. So in 2017, when we joined PTC, we added spatial applications to our spatial programming system, and then over the years we added these other topics, spatial multitasking, reality capture and analytics, spatial AI, that I'm going to show you some demo videos of during this talk. And in building all of these demos, kind of a consistent thread throughout this talk, we've been building out a platform underneath these, which is multi-user, it's real-time, it's modular and extensible, and it conforms to web standards. And so this talk is also, it's not just a sequence of demos, it's also a discussion and a story of how we've built up this really enabling platform for spatial computing. This first demo is an industrial version of the Reality Editor project from 2018 that we took from MIT and we brought it into the factory. And this is how you can use an augmented reality device to program the connected factory. So you point your phone at these machines, and you see user interfaces on them that let you do drag and drop spatial programming to orchestrate the logic between the different machines. So in this case, I took the weight sensor of the scale, I connected it to the conveyor belt of this feeder machine, and it allows me to fill up a certain amount of weight on this machine. And rather than doing this on a desktop computer where you might need an expert programmer or an automation engineer who's been trained on this for years, basically anyone can figure out how to operate this. And so it really leverages that spatial context in order to intuitively complete this task. One other thing that I wanted to mention about this that I've just really loved about this project ever since day one is that this machine and this spatial computing system that we've built continues to function and continues to persist even after you put your phone away. So this isn't just an augmented reality experience for the sake of AR. It allows you to put your intentions into the world, and then that spatial computing system exists and continues to function regardless of whether you're participating with an augmented reality or virtual reality device after that. And on that theme of persistence, we started to build new UIs that you can drag and drop into this environment and program them up against different machines. But sometimes augmented reality is the best tool for the job. And in this case, wiring up the sensor values to these UIs really is intuitive to do in augmented reality. But there are times when you might just have a big screen next to you, and it's easier and maybe more convenient to just view the data on a 2D screen instead of in AR. So we built this tool that actually lets you use the same AR app to drag and drop content and pull it out of connected screens, compatible screens that are running this environment. And you can then take augmented reality content that you've programmed up to your industrial machines, and you just pop it into a screen, and then it becomes visible for anyone in that room to be able to view. And so we try to use the best medium for the job in order to solve the problem that we're solving. And then sometimes spatial computing can be solved on a flat 2D screen as well. In addition to programming up industrial machines, we started to explore more some of the core platform layer user interface paradigms that might be useful for solving spatial problems. And so inspired by desktop computing, where you have these window managers where you can minimize and maximize applications, and you have icons that you can click on, we built kind of a similar concept. Oops. Let's see if that, oh, can't get that video to play. But basically, we built a similar concept into our augmented reality system where you could build what we call spatial envelopes. And those are these augmented reality icon applications that you can tap on, and then they expand, and you get some 3D augmented experience inside them. And they allow you to do multitasking in augmented reality by having these kind of modular sets of applications that you can pop up and close down as you need them. And as I said, our whole platform is web-based, and we wanted to really provide an open ecosystem for people to build new applications that can coexist with the spatial programming and all these other capabilities that we built. And so this slide is a little bit technical, but essentially what we had to do is build out a bit of our own 3D rendering pipeline in order to make this all work, because we sandbox the programs and the applications that third-party developers can build in our platform inside of iframes. And so we had to build this WebGL composition layer that can take these 3D applications that exist in different iframes that are maybe created with 3JS or with some other kind of 3D web library, and it can compose their WebGL draw commands into a single layer. And so those past two slides are a little bit abstract, but this is an example of a demo that those enable. This is a robotic path planning use case. And so we have this spatial path planning envelope that we drop onto a robot. We program it up to the robot with the spatial programming, and then we can drop in individual mission path points, drop them onto the ground intuitively using augmented reality. And then when you activate this path, the robot will receive the path data and use its own onboard mapping and navigation systems to travel from point to point while avoiding any obstacles. And I think this is a really interesting demo for spatial computing because it combines two different perspectives on that term, spatial computing, that I think some people have different definitions for. On one hand, you have a human-centric perspective of spatial computing, which if you're a head-mounted device manufacturer or an augmented reality enthusiast, you might think of this perspective first, which is really spatial computing as this 3D virtual world that you can participate in through this user interface, and you have all kinds of user interface elements and systems that let you be part of the system. But then there's also a world-centric perspective on spatial computing, which maybe a self-driving car company might think about more, or a warehouse automation company might think about, in which you have mapping systems and autonomous agents that each have sensors that can sense their position relative to other agents in the world, and they form their whole own spatial computing system that might not even involve any kind of a human input to it. And that previous demo that I showed with the robot really brings those two worlds together because it provides a user interface to that world-centric spatial computing system. And at the Reality Lab, we've really been interested in building a platform that enables and facilitates that full spectrum and how they can come together. Some more work that we got into from 2019, 2020, and onwards involves spatial motion analytics. So this work involved us mounting some Kinect cameras onto the ceiling to track the motion of people. And then you could see all sorts of different visualizations on how people have moved through the space relative to the motion of robots or the position of other objects in that space. And we can give you all sorts of ways to break down that information, including in that last little demo there, those colored rectangles that you can drop into the scene. We call those virtual spatial sensors. And they are kind of bounding boxes that will measure when people intersect with a certain spot in the scene. And then it can segment the work into a timeline of how much time was spent in between each of those steps that you have outlined. And so that's a little bit of a recap of the first few years of work at the Reality Lab, from building out spatial applications and spatial programming to the screen UIs, the robotic path planning, and the human motion analytics. We took that state of the platform in 2020 and we open sourced it as the Vuforia Spatial Toolbox. That consists of an augmented reality iOS app that lets you participate in the system. And it also consists of an edge server that you can run on your own computer to host your spatial computing experiments. And that edge server also supports an add-on system that lets developers build extensions for the system. For example, building new plugins for different types of robots to allow them to connect to those paths, or building new 3D UIs that you can drop into the system. This next chapter of the PTC Reality Lab, basically the last 4-ish years, we focused more into the reality capture perspective, diving into a variety of more advanced 3D spatial applications that we can build that run in this environment, as well as getting a bit into what we call spatial AI, which I'll touch upon at the end. A bit of the motivation for this work was a collaboration that we did with Dr. Matt Carney at the MIT Media Lab. He works in the biomechatronics group building robotic prosthetic legs. And he came to us with the problem that he has all this data that's really spatial in nature. It's like the force values on the heel as someone is climbing a set of stairs or walking around a room. And he can only visualize that right now as a 2D graph on a screen. And so for him, it's really hard to correlate that abstract, flat view of the data with the actual motion of a person in space. That was one of the motivating factors that led us to build this architectural scale, real-time spatial digital twin of our lab, where we mounted a whole bunch of different Kinect cameras on the ceiling of our lab, and they're all recording and calibrating their volumetric video data into the same space to create this really living, breathing, virtual version of our space where you can see the motion of people, the motion of robots. You can see IoT data, basically all the same interfaces that I showed with the spatial programming work, all overlaid into this virtual environment that someone could join in remotely and take on any perspective that they want and really see how people and robots and material and objects and machines all kind of coexist in this virtual hybrid spatial computing world. This is for me, this is a really cool demo. I think it feels pretty magical to be able to dive into that remote view of a place. But it was really cumbersome to actually set that up. We had tons of cameras mounted on our ceiling and metal rigging that we had to set up with cabling and a powerful PC that's running the latest GPU. And really, all of it was pretty hard for us to share that kind of work with people who could benefit from it and build things on top of it. So what we did over the next couple of years is to try to make it more accessible. And so we leaned more towards accessible reality capture technologies. In this case, we can use an iPhone to create a LiDAR scan of a space to create kind of a static 3D-based mesh model of an environment. And then we can open that up in a web browser and just map in live video data coming from a smartphone, which we use the LiDAR data to get volumetric video where we can map that into the scene. And that gives us this really interesting 3D collaboration platform where you can see the motion of someone in a space, and you can guide them around. Like basically, a local user and a remote user can collaborate together in that virtual environment just through the web browser. So in that bottom right-hand corner, you can see there's a view of the iPad that the local user is seeing. And they can basically see the exact same thing that the virtual remote user can see in that virtual reality view from their laptop screen. So that was really cool and useful for remote collaboration. But we found that this platform has just been useful in a lot of different and diverse and unexpected ways. So in this case, we brought in the motion analytics, and we're doing real-time ergonomic studies using that same technology. So we put an iPad on a tripod. We mapped it into that environment after scanning some work cell where someone's doing a work process. And we're able to basically automate something that previously someone would need to fly to a location. You would need an expert to analyze and annotate the ergonomics data of someone performing a task. And now this can just be recorded once, and you can review it, and it automatically segments all the data. And anyone can join into this session later and just view this regardless of where they are. Another very different use case that we found that we could use this for was this collaboration with NASA and the MIT Media Lab, where we, instead of scanning a space, we imported a scan, in this case of the moon surface, and we built a spatial application called the Spatial Measurement Tool, which allows you to do different types of geological and topographic analysis of a space and measure paths and distances and areas. You can measure the height of a crater or measure the volume of soil that might need to be excavated to level an area to build a moon station there. And so again, it's just, we've found that this platform has been able to kind of stretch to meet any kind of a use case or an idea that's spatial in nature that we wanted to solve with it. In addition to analyzing the shape of a space, we've also found that this platform could be pretty interesting to analyze how a space changes over time. So in this case, we turn on this track changes feature. It's kind of like track changes in a Microsoft Word document, but it's tracking how the volumes of space change over time. And so if you add an object to the space, it highlights it in green. If you remove something from the scan, it highlights it in red. And that could be used, for example, in tracking inventory management or how materials flow through a space, or seeing how something has been modified over time. And I added this slide in here because I think overall this platform has kind of turned into a playground for these spatial applications. So basically, we have this whole growing set of spatial applications that we build one at a time to fulfill some certain use case. But they're all intercompatible with each other, and they all run in that same platform. So for example, you could load in a CAD model. You can annotate it with a drawing tool. You can add text notes in there. You can mark things up with measurements. You can connect it with IoT data and do the spatial programming. Basically, anything you want to do in this kind of 3D collaborative virtual environment, you can do here. And it even supports applications that are built by third-party developers. So you can basically just paste in a web link to a 3D application that you've built with a certain library embedded in it, and it can render in this scene and coexist with all of these other applications. In the last couple of years, we've been looking more at some AI-powered features. So in this case, we've been looking at improving the quality of the scans that we can do. And so we enabled a full end-to-end Gaussian splatting pipeline in our system so that when you're creating that kind of low-quality LiDAR scan of a space, in the background, it's also training images to create a splat file that will, when it's done training, give you that much higher resolution view of a space. And that can support all sorts of new use cases like a remote design review, for example. So rather than having to fly to a place and get people together in order to look at some piece of furniture and see if the stitchings look right or if you need to change something, you could just do that all virtually here in a web browser. And then kind of the next kind of hot topic right now in AI is integrating chatbots with the system. And so this was actually a demo that we built in 2019. I cut out the audio just so I can talk over it. But basically, you could ask the system with your voice some basic questions about the state of the IoT system, like what's the value of the scale, or you could even start to interact with the spatial program of that machine. So you could tell it to connect the green button to the conveyor belt so that it would basically reprogram the machine with that spatial program. At the time, though, in 2019, we didn't have large language models. GPT wasn't around yet, so we had to use a fairly narrow set of cases that we had programmed it for. But obviously, things have changed recently, and so we've taken a renewed interest in this type of work. And we have a new GPT integration with our whole application that can take in our data model of space and these applications and reach into the data of the spatial applications that we've added into the system so that you can ask questions like, tell me about the current state of the motion study, and it can give you a rundown of the different steps that it's detected. In this case, there's steps that some people have annotated with additional data. But you can also do things like, tell me how much time it took for the person to walk from here to here while you're pointing your mouse cursor into the space. And it can basically use your user input with your cursor position when you're asking those questions to add new spatial applications into the space that helps it to solve those problems and basically calls the right APIs on these spatial applications in order to complete the request that it needs. And so in this case, it can tell you that it took the person 58 seconds to get from that first station to the third station. And I think this is pretty cool, and it's something that we've only been working on really in the last few months, so there's definitely a lot of more territory to explore this part. So that's kind of a recap of the basic projects and that research arc that our lab has been on over the last better part of a decade, and I guess more than a decade if you include the MIT time. I also wanted to just touch upon kind of a theme that goes beyond any one individual demo that we've been building, and that's that as we build each demo, we've been building out a platform in order to support those demos that we're building. And incrementally, this has been leading us to build what I'm going to call an operating system for space. Basically, in order to enable one of these demos, like the spatial programming, we had to add some new core capabilities to our platform. It needs a spatial data model. It needed to be able to handle augmented reality image tracking. It needed to have these spatial data nodes that have IoT values associated with them, can support 2D UIs, some multi-user synchronization, and hardware interfaces to connect to the physical world. But then when we had a new set of demos that we wanted to build, for example, the robotic path planning or the AR screen UIs, those features that we had built in the core were really helpful. That kind of facilitated building those new demos, but they weren't sufficient on their own. And so we extended that platform that we had with new features and new capabilities. We added more complex data types that those nodes could support to support the path planning use cases. We added that distributed render pipeline so that we could handle 3D UIs. We added that concept of spatial envelopes that I talked about for spatial multitasking. And so basically, by building this next set of demos, we had to extend that platform. And we just continued this pattern year after year for basically the past decade. And it's been able to stretch the system, and not just stretch it, it's carefully constructed, but basically expands the system's capabilities with each new generation of demos and capabilities that we want to support. So with that holoportation demo and the remote spatial programming, we had to add some support for volumetric video. We added that desktop viewer so that it's not just a phone-based augmented reality app. We added a concept of like a world object that can handle a whole scene instead of just one IoT object. And so just year after year, we just kept expanding and building out this platform bigger and bigger and able to support a wider variety of spatial computing kind of operations or use cases. And we've done this mainly in an industrial context, but you've also seen how this platform can be used in non-industrial ways. For example, the measuring paths on the moon surface, or I don't know, just drawing or adding games into a space. So I think this is also a pretty flexible platform to be used in a wide variety of spatial computing and XR use cases. And so this is pretty much where we are now. We have built out iteratively a platform that we have tested and retested with demo after demo and experiment after experiment. And I think the term operating system is kind of a lofty goal, and maybe I'm stretching the definition of that a little bit. But I think that is what we're becoming closer and closer to realizing with this platform that we're building, is this platform that can handle both that world-centric perspective on spatial computing, as well as the human-centric perspective on spatial computing, and a platform that is built on web standards. It's open and it's extensible, and really can be used to enable XR more widely. And yeah, that's what I have for today.
We probably have time for one question. Could you just come right up to the mic, please?
Hi, PTC's a CAD company at heart, right? And recently you showed off, you took the Onshape product and you created an XR application. Can you talk about whether what you see in the future, not necessarily just for that product, but in terms of taking your average CAD user who's right now not using XR mostly, and then starting to incorporate that maybe while they're designing in CAD or maybe doing design reviews? Do you see a future in that? What do you predict happening there for PTC and or the CAD industry overall? Thanks.
Maybe I'll call in Valentin for this question.
You want me to jump in? Is the microphone on? Yeah. So I think this is a good question, because I think we do have these capabilities already. I think there's an Onshape application that you can capture area targets and bring them into this environment. We have a really interesting Vision Pro app that we launched for Onshape that is a collaborative application, a spatial application. So you see we have Vuforia as an enabling core platform that we bring into all of our products, right? It's omnipresent in PTC. Does that answer the question? Cool.
Sorry, we don't have time for another question.
You'll find us outside if you want to ask more.
I was just going to ask if you'd be available. Thank you very much. Can we have a round of applause for our speakers today, Valentin and Benjamin?